This one says to determine if the series is convergent or divergent. Doesn't tell me what kind of a test to use. If I consider the integral test, as I'm looking at this, if I had this as a continuous function, it would be continuous from 1 to infinity, and it would be positive terms from 1 to infinity, and it would be decreasing. So I can use the integral test. Let's go ahead and do that. We would have the integral from 1 to b, limit as b goes to infinity, of 1 over, I'm going to rewrite this as x to the 3/5 dx, and in fact it would be even better to write that as a negative exponent so we could think about integrating. So this is going to be x to the negative 3/5 dx. So we essentially are going to have a power rule in reverse, and so we have the limit as b goes to infinity of this would have been 1 higher power, which would have been x to the 2/5, and then we need the reciprocal of that power out in front, and we got to evaluate this from 1 to b. Now as we look at that, we have the limit as b goes to infinity of 5/2 b to the 2/5 minus 5/2, and if we put in a 1 here, that will just be still 5/2. So now we look at this and we're interested in whether this converges to a finite value or whether it diverges. And we've got our finite value here, but looking here, we have this root on it, but we are going to continue to have b become larger and larger, and so this is going to go to infinity. So this is going to diverge, and therefore this series also diverges. Now, that worked. The integral test worked on this, but there was an easier way to do this. We could express this as 1 over n to the 3/5, and we're again looking at the sum, and this we could recognize as a divergent p-series, because we learned that if we have 1 over n to the p, if p is less than 1, which it is here, it's 3/5, it's going to diverge. So we could get there very quickly by using the p-series test and just recognize this as a divergent p-series. And the integral test works, but we don't have to go to all of that work if we can express it thinking of a p-series.